Hi, I'm Paul Battaglia, and this is section 2.6. Students come into section 2.6 having looked at a variety of functions, and their inventory now is quite large. But it's time to look at two more types, inverse functions and specifically inverse trigonometric functions. So the essential question we would like students to answer at this point is, how do I derive inverse functions and how do I derive inverse trigonometric functions? I think a great way to start off here is to look at a graphical exploration. This will help us address impact number 1, making a conjecture based on the use of a graphing utility. Now, along the lines of these last couple sections, we've also been addressing mathematical practice number 6, trying to select appropriate strategies for how to derive some of these problems. What might be best is, after maybe an exploration, we remind the students, what is an inverse function? How does it look? Remember that an original function has points x, y, and an inverse function has points y, x. So then we move into Theorem 2.17. And in this theorem, we talk about the rule necessary for deriving an inverse function, which can be very abstract, and the notation can be a little bit tricky. Often in these times, what I'll do is I'll give my students a different notation. For instance, I might say the derivative of a function at point A times the derivative of the inverse function at point B is always equal to 1. And that really goes hand in hand with what they see in Theorem 2.17. But it does create a common mistake sometimes, so I have to be careful. And that mistake is for students who start to conjure up images of an algebraic rule that seems eerily familiar, but not the same. And that is that the slopes of two lines that are perpendicular are negative reciprocals. So caution your students, not the same thing. Where do we go from here? Well, we go to Theorem 2.18, which lays out the derivatives of all 6 inverse trig functions. What's important to note here is on the AP exam, the two most widely used and the ones that students should focus on are arcsine and arctangent. The next thing students need to be able to do is put all of these functions into a big box. So there's a couple things we can do for closure. Perhaps we can suggest that they try and write as many rules as they can remember. Maybe just make it a little bit fun. Make it timed. Make it a contest. And along those same lines, there's a game I like to play with my students after I've covered many of these rules of differentiation. It's called Duringo. Here's how it works. It's very similar to the game Bingo. All my students would get a board. Maybe it's 5 by 5, 25 squares in all. And all of the squares are filled with answers, derivatives of original functions. Then they'd get a separate paper that has 25 problems. And then the race begins. We're asking students to derive those 25 problems, find their answer on the board, and then just as in Bingo, we're looking for the students who come up with 5 down or 5 across or 5 diagonally, and who can do it the quickest. Now, naturally, some students are going to lag behind a little bit, and this is not for anything more than for them to have a little bit of fun and for me to assess which students know the product rule, the quotient rule, the chain rule, all of these inventories of functions we've been talking about. Who can derive what? What's giving students problems? Those are things that I can assess even though they're having fun playing this game. And the rule is that you don't win unless at the end of your session you get your 5 boxes. You must yell Duringo. Corner, yes, but the students have a good time with it. Let's talk finally about how we would handle some of this stuff on the AP exam. I think what we want to expose our students to is we want to expose them to tables. We want them to see not just functions, but we want them to see this in a different light, not just analytically, numerically. Can you take a table of values and can you find the derivative of an inverse function? You might extend it a little bit and you might say, can you write the equation of the derivative of an inverse function or the equation of a tangent line to an inverse function? These are things that we want students to try and pick up on and extend the learning experience. I hope these tips have been helpful. I'm sure you'll find much success in section 2.6.